Exercise. Project name, Blynk Garden. Preparation, 1 soil moisture sensor module, 1 relay for a water pump, 1 relay for a light, etc. Requirements, adding the location to the device. Let users add Wi-Fi credentials and Auth token to the device themselves. 1 switch on Blynk.Console, the color of the switch is normally green, to turn on off the water pump relay. Allow users to reboot the device from Blynk.Console. The device can update its new firmware remotely. 1 button on the hardware to turn on, off the water pump relay. Synchronizing the water pump relay state between Blynk and hardware after turning on, off from both sides. Synchronizing the water pump relay state between Blynk and hardware after the device is online. 1 label on Blynk.Console to present the soil moisture sensor value. Updating the soil moisture sensor value every 1 minute to Blynk with this format. 1 switch on Blynk.Console to turn on, off the auto mode. The auto mode, turning automatically on, off the water pump relay based on the soil moisture sensor value when this mode is on. If users control any relays from any sides by using different functions, then the auto mode will have to be off. If you turn on the water pump relay when the auto mode is off, and then the soil moisture sensor detects that the soil moisture exceeds the threshold, then you need to change the color of the switch to red and show an event. Show the event in Notifications and Events section. Be able to schedule to turn on, off the water pump relay. The light relay turns on when the sun sets and turns off when the sun rises automatically. 1 image gallery to present the value of the soil moisture sensor. Example. When the soil moisture exceeds the threshold, the image gallery presents a corresponding image, otherwise presents a different image. Creating a scene, this scene is used to turn on, off all relays. When the event is triggered, send an email to users to warn them. To install Arduino IDE, you first need to access this address. On this page, you can see the download options on the right side. I choose this option, which is suitable for my Mac. I don't force you to click the Just Download button like me. You can research on your own to download in another way. After downloading, you double-click on the file. Drag Arduino IDE to the Applications folder to copy. After copying, you can see Arduino IDE is in the Applications folder. You can drag it to the dock like this for convenient use later. Open the application for the first time, receive a notification. The part we should be most interested in this notification is about the following text. Apple checked it for malicious software and none was detected, from which we can see that this is a seemingly safe software to open. So the installation of Arduino IDE on the computer is complete. Next, we need to install the command line developer tools. We click the Verify button here to show the installation notification. This way may not be official at all. After we click Install, the license agreement will appear on the screen. I am not responsible for your clicking the Agree button, but you need to agree to it to continue. After the installation is complete, we click the Done button. Next, we install the ESP32 board on Arduino IDE. We go to Google to search with installing ESP32 in Arduino IDE. Here we should select this result. I think this is the official documentation page from Espressif. Scroll down. We copy the stable release link. Go back to Arduino IDE. We go to Preferences. Scroll down below. We paste the link here and click OK. Then we go to Boards Manager. Type in the search bar the keyword ESP32, and you install ESP32 by Espressif Systems here. Next is to install the Blynk library. Select the Library Manager tab. Type in the keyword Blynk. Install this. A notification appears. This notification can be roughly understood as the Blynk library in this version has one accompanying dependency. We should install both. So we click the Install All button. First, you need to access this address. To log in, you click on the Log In button. If you do not have an account, click on the Sign Up button here to register. After the first login, you will probably be redirected to another interface, but you can go to the interface yourself like me now, right? I don't think it's difficult. On the left, there are many different tabs. For starters, I don't force you to know all of them to be able to create a template. To create a template, click on the Developer Zone tab here. After clicking, we will default to the first tab in the Developer Zone tab. Specifically, the first tab here is the My Templates tab, which is the tab we need. You can read here to know what a template is, or you can access the documentation page to read. Now we click on the New Template button. With the hardware and connection type information fields, they already have the default values that we need. We need to give a name to this template, and for the description information field, you can leave it blank. Click on the Done button. After we have created a template, we can use this template to create devices. You can visit this documentation page to know what the term device is used in Blynk. To create a device, we go to the Devices tab. Click on the New Device button. And there are a few options here. We use the method of creating a device from a template. We choose an available template that we want. Here I name the device. Click on the Create button. Let me show you a page that is probably official from Blynk. You can get the sample code there. You go to Google and type the keyword Blynk example. You choose the first result. On this page, we can find the appropriate sample code by customizing the first two information fields and one information field at the end. Here I choose the board as ESP32. The connection is ESP32 Wi-Fi. And the example is default. After choosing the sample code, click on the Copy Example button here. We go back to Arduino ID. Replace the current code with the copied code. Here we need to replace the sample information with our information. The template ID and template name are of the template, and the auth token, each device has a different auth token, at least for devices in the same template. We can get all three of these information on the device side. You go to the dashboard of the device. Click on Developer Tools here. Scroll down. Hover your mouse into this gray box and click to copy. We go back to the Arduino IDE and replace the sample information with the information we just copied. Scroll down. The SSID and pass information can be said to be the name and password of the Wi-Fi network that the ESP32 board will connect to. This Blynk.begin command, you can go to this page to read to know what it does. Roughly, it is a command to configure. Next is the Blynk.run command. It is a main Blynk routine responsible for keeping connection alive, sending data, receiving data, etc. You can read more information regarding this command here. This is the ESP32 development board type I use. Next, I connect the board to the Mac. You may need to select the board and port to suit you. In my case, the board and port have already been selected. Now we proceed to upload the code. You click on the Upload button here. After uploading the code, the program in the board starts running, and we will see the device here showing online status, which means the board is probably connected successfully. The two main functions of an IoT system are probably monitoring and control, right? The content of this video is related to two widgets, one widget for control and one widget for monitoring. The widget for control is switch and the widget for monitoring is label. You can go to this page to read information related to the switch widget, and this page to read information related to the label widget. You click on the Edit Dashboard button here. You drag the switch widget into this canvas. Next, you find the label widget and drag it into the canvas too. Okay, now let's customize the switch widget. We click on this gear-shaped button. You can name it here, for example, this switch widget is used to turn on off the fan. You can name it here fan. Below, we can see the term Datastream. So what is Datastream? Datastream is a set of digital signals used for different kinds of content transmission. In addition, you can go to this page to read information related to data streams. To create a data stream, first click on this button. There are three options here. I choose virtual pin. If you want, you can research the other two yourself. There are too many things here, right? In my opinion, when you first start, you can think of Datastream as a variable in programming. A variable also has a name and data type. We name and choose the data type for the Datastream first. I name the Datastream. In the data type information field, there are only two options. I choose the data type as integer. Click on the Create button. And click on the Save button. Next is the label widget. We click on the gear-shaped button too. For example, this label is used to monitor the temperature. We can name it temperature. We do not use the same data stream with the fan switch widget, but create a new data stream. Name it. Choose the data type. This time we choose double. In the units information field, I choose degrees Celsius. And now how to set the two information fields min and max. If you use this label to display the temperature value of the DHT11 sensor, you can refer to the measurement range of the sensor to set. You go to Google, search with the keyword DHT11 datasheet. You choose this result. I think Mouser.com is a good website. Scroll down. Look here, we know the measurement range of the sensor is 0 to 50 degrees Celsius. Okay, we click on the Create button. Click on the Save button. And click on the Save and Apply button here. The main content of this video is about sending data from hardware devices to Blynk. First, you prepare a starter template sketch like this. Now we find the command to push data to Blynk. You go to this page to see an example related to sending data. This is the main command. We go back to the Arduino IDE. To keep the code clean, I think you should write a function to send data separately outside the loop function, like this. Paste the command here. In the sample command, we see that there are two arguments passed in. The first is the name of the pin of the datastream, followed by the data to send. Here are some examples of using this command. You can refer to it. And you may wonder how data flows from device to Blynk. When you send data to Blynk, it flows through a data stream using Blynk protocol. Then every value is automatically timestamped and stored in the Blynk.cloud database. Okay, in this video, I transmit data to Blynk. And this widget label has the task of displaying that data, so we need information about the data stream of this widget label, specifically the pin name of the data stream. We click on Developer Tools. Select the Data Streams tab. Here we see two data streams. This is the data stream that has been created for the widget label. You hover over the name of the pin. A tooltip appears. You click here to copy. Now we can paste it directly here like this, but in my opinion you should give it another name instead of just v1. You write a macro here. Here I assign the result of the random function. Later you can assign the magnitude of the temperature value of the DHT11 sensor here. We change the name of this function to describe its function more closely. But this name still does not describe its function well enough. From line 25 to the end of line 28, there is the following main content. Every 1 second the device sends temperature data once. Now we connect the board to the Mac. After selecting the board and port, we upload the code for the board. Okay, now we return to the dashboard interface of the device in Blynk.Console. We can see that the board is connected, and the value of this temperature label widget is changing every second. This video has content related to the BlynkTimer object. You can refer to this page to read information related to timers. Before we begin, first you should know, Blynk library offers a built-in Blynk.timer feature to send data in intervals. It allows you to send data periodically with given intervals and not interfere with other Blynk library routines. Let's start with the code like this. We will get some code from this page. Okay, now let's see what's new here. First, at line 14, we initialize an object named timer. This object belongs to the BlynkTimer class. Next is line 23. The setInterval method is now passed in two arguments. The first is a time interval, the next is a callback. At line 28, if you want to know what this command does, you can refer to this comment. And this comment, I think this comment is correct. After the template, the newly added code has the following content. Every 1 second print the result of the mealy's function one time. Now we upload code to the board. Every 1 second print the result of the mealy's function one time, right? Next, we can apply BlynkTimer to send data to Blynk. You can continue to use this timer instance to schedule another timer. This time we will use serial to print the result of the millis function every second and send data to Blynk every 2 seconds. For the value of the temperature variable, I no longer use the result of the random function, but instead use the result of the millis function converted to seconds. Every 1 second here, and every 2 seconds here. This video is related to this function. Information related to this function you can read here and here. Okay, we will start with the code like here. You copy the sample code here and paste it here. In this video, we will write code to get the on-off value of this fan switch widget. That is, when it is on, the board receives the value corresponding to on, and when it is off, the board receives the value corresponding to off. This function requires passing in a parameter which is the name of the pin of the datastream. Here they use the method asInt. Why? If you read the two comment lines above, you can understand that V1 is the name of a pin in the datastream, and this datastream is for a widget which is a slider. If you create this datastream for the slider widget, you can only choose one of two data types, which are integer or double. Maybe here they chose the data type as integer. So how does this function work? This is a special function that is triggered automatically whenever the server tells your device that the value of your virtual pin has changed. You can understand that when people slide the slider and change its value, this function is called. So how do we get the value of the slider? When the BlynkWrite function is called at the same time, from this param, you can access many methods whose return value can be equal to the current value of the slider. Okay, now we will apply this special function with this param to get the value of the switch every time the switch changes its value. We click here to open the developer tools. Click the Datastreams tab. This first row is the datastream used for the fan switch widget. Here we need to know two pieces of information: the pin name and its data type. Knowing what the data type is can help us in calling the method to get the data. For example, we already know that the data type of the datastream used for the fan switch widget is integer, so here we use the method asInt instead of as string or as double. Now we upload the code to the board. Okay, on state corresponds to 1, and off state corresponds to 0. If you use as string or as double method, you can still get the same result. But consistency should be a priority, right? This video has content related to this function. First, you can read information related to this function here. If you have not read it yet, the following information is what you need to know first. When the hardware device connects to Blynk, the content in this function will be executed. You copy the code by clicking on this button. We go back to the Arduino IDE and paste the copied code here. In this function, we write a line of code to make the serial print out a string. Like this. Now we upload the code to the board. After uploading the code, you disconnect the power of the board to disconnect the board from Blynk. Wait a moment for the online status to change to offline. Now I connect the board to the Mac. On the dashboard interface of the device, the online status is displayed at the same time as serial has printed out the string Blynk connected. You can see it in the serial monitor. This video is about syncing with latest server value every time device connects to Blynk. The following is an example. For example, a user owns a Wi-Fi connected dimmer light. The device goes offline. User sets the brightness of the light to 100% in the mobile app or on the web. When the device comes back online, it can request the latest value from the server and set brightness to 100. Below there are some sample commands such as Blynk.syncAll, Blynk.sync, but in this video we will use this command, Blynk.syncVirtual. You can see information related to this command here. This command updates individual virtual pin to the latest stored value on the server. When it's used, a corresponding Blynk write handler is called. At Arduino IDE, to start you prepare the code as here. The code of starter template sketch this time has an additional function Blynk connected. Because it is related to synchronization, the synchronization command and this function will be combined together. For testing, I need to add another switch widget. You click on Edit Dashboard. Drag another switch widget here. Name it Heater. You create a new datastream. Name the virtual pin datastream. Click on Create. Save. And save and apply. Here I have a schematic you can take a look at. And here is the circuit I assembled on the breadboards. Here you write some macros for the pins of the module. The fan button pin for pin 26. The heater button pin for pin 25. The fan LED pin for pin 33. And the heater LED pin for pin 27. Below, you write macros for the virtual pins of the data streams. The fan V pin for pin V0. The heater V pin for pin V2. Using synchronization, you need to write a Blynk write function for the corresponding pin. Initializing two variables to store the current state of the fan and heater. Assign the value received from Blynk to fan status. And assign the value received from Blynk to heater status. Set the mode for this pin to output. And the same for this pin. To continue, I need to install the button library. Why do I need this library? Here you can read that button is a tiny library to make reading buttons very simple. After installation, let's see its example. In this video, we just need to catch the button event being pressed. That's enough. First, we add the button library. Next, we initialize the button object. Here is the heater button. And here is the fan button. We pass the corresponding pin arguments to the constructor function. In the setup function, we call the begin method on the fan button object, similar to the heater button object. This method is placed in the loop function to catch the button press event. We need to catch the button press event for both buttons. After pressing the button, we reverse the status of the fan, similar to the heater. We update the fan status to Blynk. The heater is similar. In the Blynk fan vpin function, after receiving the status of the fan switch from Blynk, we update it to the hardware pin. In the Blynk heater vpin function, it is similar. You copy the sync command here and paste it into the Blynk connected function. First, I will show you how to sync one virtual pin first. Now you upload the code to the board. After uploading, we check if it works well. First, turn them on from the hardware side. The status of the fan and heater is also updated to Blynk accordingly. Next, turn them off from the Blynk side. The status of the LEDs for the fan and heater on the hardware side is also turned off accordingly. Now we will check the synchronization. We need the hardware side to disconnect from Blynk. To do that, we can turn off the Wi-Fi transmitter that the hardware side is connected to. On the Blynk interface, you may have to wait a while to see the offline status. In fact, after you turn off the Wi-Fi transmitter, you can still see the online status of the device on the Blynk interface, but in fact, the device is offline after you turn off the Wi-Fi transmitter. After the device is offline, you change the status of the fan and heater switches so that it is different from the hardware side. Then you turn the Wi-Fi transmitter back on. After the device connects to Blynk, the LED representing the fan status is on, similar to the fan switch status on Blynk. This shows that we have successfully synchronized the value of the fan virtual pin. Now we will write code to synchronize the heater as well. You upload the code to the board. The status of these two switches is currently also the status of the two LEDs on the hardware side. When the device is offline, we turn on these two switches. When the device is online again, you can see that the status of both sides is synchronized. Here I do not include the temperature value. You may find this code confusing. The code about syncing one virtual pin. When the device connects to Blynk, this command will be executed. This command will ask Blynk to send the current value of the fan virtual pin on Blynk. When Blynk sends the value of this virtual pin to the hardware device, the content in this function will be executed. This video content is related to this command. You can see information related to this function here. To get started, you should first know the following information. The Blynk.syncAll command restores all Datastream's values based on the last saved values on the server. All analog and digital pin states will be restored. Every virtual pin will perform Blynk write call. Below it is the following information. Blynk.syncAll returns data only for the data streams marked as sync with latest server value in your template setup. To mark sync with latest server value for data streams, you go to the Blynk interface as shown here. In the dashboard of the device, you click on Edit Dashboard. You go to the Data Streams tab. In this video, we will synchronize the values of both data streams. You click on the first row, scroll down. Expand Advanced Settings. You turn on this switch. Click Save. Similarly with the second data stream. Click Save and Apply. This is the start code of this video. We need to add the sync command to this Blynk connected function. Copy and paste here. Now you upload the code to the board. We turn on the fan and heater from the device side. Turn off the fan and heater from the Blynk side. Turn off the Wi-Fi transmitter that the hardware is connected to. After the hardware device is offline, we change the status of the two fan and heater switches. Turn on the Wi-Fi transmitter. After the device is online, both LEDs will light up corresponding to the switch status of the fan and heater on Blynk. That shows the sync worked. This video has content related to this command. You can go to this page to see information related to the command. First, you should know the following information. The widget property is a widget attribute like color, labels, min/max, and others that could be dynamically changed from the hardware or HTTPS API. The starting code of this video you can see here. This starting code contains the Blynk connected function, which you can consider it as a place to set up after the hardware device connects to Blynk. First, I will change the color of this widget. Here, you copy the sample command. You go back to Arduino IDE and paste it here. This sample code, you can see it has been passed 3 arguments. The first argument is the name of the datastream pin. The second argument is the name of the widget property. The third argument is the value of the widget property. If you want to change the color of the heater switch widget, you must first know its virtual pin. Click on Developer Tools. Select the Data Streams tab. Now you know its pin name is V2. Click to copy pin. We pass the pin name here. I want to change the color of the heater switch widget to a color like red. For the third argument, it is required that the value assigned to the color attribute must be a string in HEX format. You can go to this page to get the color value in HEX format, and you can get the color you want by adjusting the 3 red, green, and blue bars. Now you upload the code to the board. Currently, the device is offline. After the hardware device connects to Blynk, the color of the heater switch widget changes. So we have successfully set the value of the color attribute to another color from the hardware side. Next, we also use that command to change the color of both of these switch widgets. Also on this page, now you click on multiple data streams. You copy this command. Paste it below the previous command line. We will change the color of these two switch widgets. The two switch widgets use pins V0 and V2. I will assign them a different color. Finally, you upload the code to the board. After the hardware device connects to Blynk, the color of both widgets has changed to the same color as I set. The content of this video is related to event. So what is event in Blynk? Event is generic concept that allows to track, log, and work with important events that happen on the device. And you can read here. If you haven't read the documentation yet, you should know the following information first. Additionally to the historical event tracking, events can also be used for notifications which can be sent over email, delivered as push notifications to user's smartphone, or sent as an SMS. There are two examples here. You should read the first one first. Log a moment when a temperature reached a certain threshold and send a notification to selected users. Okay, in this video, we will use this command. You can see information related to the Blynk.log event command on this page. And this page also provides information related to the command. You can see here. This is the starting code of this video. Go back to the documentation. This page says, events are pre-configured in Blynk.Console and can be triggered with an event's firmware API from the device. First, we need to create an event. On this page, you click on Edit Dashboard. Select the tab Event and Notifications. Here, you click on Create Event. Choose Custom. You name the event. In this video, I used the description information field here as default description. You write a description for the event. On the Notifications tab, you turn on this switch. In the Email to Information field, I choose the device owner. Here I choose 1 second. You can consider choosing the option 1 minute below. You turn on this switch. Okay, click on Create. Save and apply. we return to Arduino ID. In this video, I apply sending information to the board via the UART protocol to trigger the event. Here, I catch the event receive data in the loop function. If the description content we send to the board has the content of default, then the program will execute this command with only one argument passed in. This argument is the event code. You need to know the event code of the event you want to trigger. Click to copy event code. If the description that the board receives has content other than default, then the board will execute this command with two arguments. The second argument I call custom description. I pass it here with the description received from the Mac. You can see the sample command of the case of passing two arguments here. You upload the code to the board. You click on Notifications and Events. In Arduino IDE, you open Serial Monitor. Here you choose No Line Ending. Now we start triggering the event from the hardware device. First, I will send the string default to the board. After typing it, press the Enter key to send it. If you wait here for a long time but do not see any new event received, you can click on the Filter option here. Maybe that is a way to refresh the data. Now, in the Notifications and Events section, you can see that I have received an event with the default description. On the Gmail side, I received an email with related content. Now I will send a different description to the board. Press Enter. This time we receive an event with a different description than the last time. On the Gmail side, I also received an email with a similar event description. First, you can go to the dashboard interface of the device in Blynk.Console as here. You click on the Locations tab. Click Create New Location. Name the location. In this address information field, for example, here I put the information as Austin, Texas, United States. I need to fill in the zip information here. I search Google with the keyword Austin zip code. I copy this zip code. Paste it here. OK. Click Done. We click on the Developer Zone tab. You click on the template that the device you want to add the location to was created from this template. The Metadata tab. Edit. Add metadata. Scroll down. Select Location. You turn on this switch. Click Create. Save and apply. You go to the dashboard interface of the device you want to add the location to. You click on Info and Metadata. You click on Edit here. This information field I choose My Location. Click on Save. The content of this video is related to getting real-time, although the time taken is not perfectly accurate. We will start with the code like here. We go to this page to get the sample code. This code requires the EasyTime library. We go back to Arduino IDE to install that library. You install this library. Next, you copy the code from the web page and paste it into the sketch like I do. Next, we edit the pasted sample code. Here you can delete the comments on this line and this line. Next, I delete the print commands here. I change the name of this function to printtime. Pass that function name here. Change the interval argument here to 1 second. Here I write the commands to print the time. Here is day. Here is month. Here is year. Here is hour. Minute. And second. You upload the code to the board. Actually, here hour is in 24H format, not 12H. So why is the local time now 1600 hours, but here it prints 4 o'clock? Based on what? On this page, you click on Info and Metadata. Here you can see that this device was added a location, so the device time zone here is America/Chicago. The current time in Chicago is 4:24. That time is similar to the hardware device time. Now, in this information field, I choose none. Reload the page. Now the old device time zone has been replaced by the new device time zone. How does Blynk get the new device time zone? It can be understood that the new device time zone is inferred from this IP address. We go back to Arduino ID. Now you disconnect the Mac and the board. And now you connect the Mac and the board again. You can see in the serial monitor, the time printed is approximately the local time. The content of this video is related to sending Wi-Fi credentials and Auth token to device. After watching this video, you can read this page. Now I'm in the Arduino IDE software. I click on File here, hover over Examples, scroll down, hover over Blynk here, Blynk.agent. Finally click on Agent ESP32 here. Here, we need to add information about our Blynk template. We comment out this Blynk Auth token information. I comment out this Blynk firmware version information. Above this inclusion, we include the Wi-Fi library. Now we upload the code to the board. After uploading the code, we will find a Wi-Fi network with the same name as here. You should note that other people can broadcast a Wi-Fi network with a similar name. They can trick you to get Wi-Fi password and auth token. Be careful. I connect to this network. After connecting, you access the following address, 192.168.4.1. On this page, I can provide Wi-Fi network name, Wi-Fi password, and Blynk auth token. After filling it, you click on the Apply button here. Now the device is connected to Blynk. To reset configuration, you hold the boot button for 10 seconds. Then you release the button. The content of this video is related to Reboot. This is the starting code of this video. You go to this page. I will copy the sample code here. I click on this copy button. We go back to Arduino IDE. Paste the copied code here. The content is in this function. For this video, I only need this command. You should read these comments once. You can keep these comments, but in this video I will delete them. Now we upload the code to the board. You open the serial monitor. You click here to clear output. You need to go to the dashboard of the device. You move the mouse here. Click on Reboot. And click on Reboot here. We do it again. The content of this video is related to OTA. So what is OTA? OTA, also FOTA, over-the-air firmware updates without accessing the device physically. For related documentation, you can see this page and this page. To demo Blynk's OTA solution, your board must first be loaded with the code related to the Blynk.agent solution, and the board must be connected to Blynk. This video will have 2 firmware versions. Here I set the Blynk firmware version to 0.0.0. The firmware with this Blynk firmware version will be updated to the board first by the method of connecting a cable directly between the Mac and the board. I need to write more code to print out the current Blynk firmware version. Okay, now you upload the code to the board. Be careful here, don't connect to other people's Wi-Fi networks. Okay, now we prepare the second firmware. Here I just change the number 0 here to number 1. The purpose of this is firstly to distinguish the 2 firmwares from each other. Secondly, in this demo, this second firmware needs to have a Blynk firmware version higher than the first one. Because later, when creating shipping, I will choose this option. Okay, now I save it. After saving, here you click on Sketch and click on Export Compiled Binary. You go to the device dashboard interface like here, click on Developer Tools. Here you click on OTA Update. You click here to select the file to upload. You select this file. Finally, you click on Start Shipping. The content of this video is related to automation. Specifically, here is schedule. So what is automation in Blynk? Automation, condition to action sets allowing devices to complete tasks without user interaction. The following is some information you should know in advance. Automations allow the end user of your app to create scenarios where the device automatically performs one or more actions based on a condition. A manufacturer or developer defines which parameters of the device can be automated by end customers. There is information about the types of conditions here, but in this video, we will demo about schedule. Schedule triggers an event based on the current date, time reaching a particular set of date, time values, all relative to a specified time zone. And here is the information about types of actions. You should know the following first two. One or more actions may be executed sequentially or simultaneously when a condition's requirement has been met. In this video, we will demo this and this. This is the starting code of this video, and this is the schematic of this video. In the starting code, first, here we define a macro. With the name of the macro is green lead pin. And the value of the macro is 18. Next, define another macro named green lead V pin. Its value is V0. You initialize a variable to hold the current value of the green lead status with the initial value of false, which means the state is off. Here, we assign the value received from Blynk to the green lead status variable. Then update the state of the green lead pin. In the setup function, we write more code to configure the green LED pin as output. Set the initial state for the pin. Now we upload the code to the board. We will create a schedule to turn on and off the green LED. This is the switch of the green LED. Before going to the Automations tab here, we click on Edit Dashboard. Click on the Datastreams tab. Here we see the datastream used for the green LED switch. You click here. Click on the Expose to Automations tab. Here there are some automation types. I choose Switch. Below there are Condition and Action. Action. Allow users to change this datastream state using automations. We turn on the Action switch. Save. Save and apply. Now, you click on the Automations tab. You choose this. You click on Settings. You name the automation here. About the limit period. You could see it here. Here I set it to 1 second. Maybe here you don't need to choose like me. Cover for the automation. I choose this one. You can click here to set a particular set of date, time values. This field is the location for the time zone you want. You choose the time here. Here, you choose the device. In this device, there is a data stream that allows changing the value. The first action after this automation is triggered is to change the value of this data stream to 1, corresponding to the on state of the switch. After turning on the LED, we wait for a period of time. In the next action, we add a delay. Here I set it to 10 seconds. After waiting 10 seconds, in the next action, which is also the last action, we set the value for this data stream to 0, corresponding to the off state of the switch. I click on Save. First, the status of the LED and the switch are both off. When it reaches 1357, the switch is turned on. Then after 10 seconds, the switch is turned off. The content of this video is related to automation, specifically with the type of condition sunrise/sunset. Sunrise/sunset triggers an event when the time before/after sunrise/sunset occurs relative to a set of defined weekdays at a specific geographic location. In this video, I will demo this type of action. Go to the Automations tab. Select this. Click on Settings, name the automation. This information field, for example, sunset at the location is at 18 o'clock. If in this information field you select 1 minute before, the automation will be triggered at 17:59. If you choose at, it will be 18 o'clock. Here you set the location. After the automation is triggered, it will send an email. You click on Send Email here. Click on Save. Now you create another automation. Still select this. Click on Settings, name it. Now here we choose sunrise. Here I choose 5 minutes after, which means the automation will be triggered 5 minutes after sunrise. I click on Save. Now we search Google to check the next time the sun sets and rises. On July 30th, 2025, the sun sets at 18:15. On July 30th, 2025, the sun rises at 5:33. Just now we selected the option 5 minutes after, so here displays the time as 5:38. There are 2 emails sent. The first one. The second one. The content of this video is related to automation, specifically with the type of condition device state. Device state triggers an action based on the value of a data stream. Here you can see that the left window is the starting code of this video, and the right window is the schematic of this video. For the light sensor module, you can see this actual image. This is the module I used for this video. This module normally, when no light is detected, the state of pin D0 is high, and when light is detected, it is low. First, we define the macros. The first macro, its name is green LED pin, and its value of 18. The second macro, its name is light sensor pin. I will edit its value later, but for now, you can give it the value of 16. Next are the macros for the virtual pins. Green LED V pin is V0 and light sensor V pin is V1. Initialize a variable to store the current state of the green LED with the initial value of false. Here, we assign the value received from Blynk to it. Then update the status for the pin on the board. In this setup function, we configure the green LED pin as output. Above, the macro named light sensor pin, it has to have a value of 16, not 18. We configure the light sensor pin as input. Set the state for the green LED pin. Here, I write a function containing the command to send the value of the light sensor to Blynk. Assign the value read from the sensor to the variable. The content of the function has 3 tasks in total. The first task is to read the value from the light sensor. The second task is to initialize a variable with the initial value being the value read from the sensor. And the third task is to send the value of the sensor to Blynk. Here, we should name the function to describe the 2 tasks of reading and sending the value of the light sensor. In the program, we need to call the function repeatedly. So here we initialize an object of BlynkTimer to schedule to call the function repeatedly. Here we set the interval to 1 second. Now you upload the code to the board. Before we proceed to create automation, we need to go to the Datastream section of the template. Here are two data streams which are used for the switch widget and label widget in the dashboard interface of the device. About the information related to automation type, you can see it in this table. In the automation type information field, we keep the switch selection. Below, we turn on the action switch. In this information field, this time we choose sensor. Below, we turn on the condition switch. Condition: allow users to use this data stream as an automation condition. Save. Save and apply. Now we will proceed to create automation. You click on the Automations tab. You choose this. Click on Settings. You name it. I choose this cover. In the limit period information field, I choose 1 second. In this when section, the first two information fields, you can understand what type of information they receive, right? The information field below needs to pass in information of the type of datastream value change. In our demo case, if the sensor detects light, the LED will turn off, but if the sensor does not detect light, the LED will turn on. The two options at the end of the list, that is, has changed and is any, you can understand these two options, right? You can know the difference between these two options through the following information. The is any option detects an update to the value for the data stream. It can be the same as prior or changed. The has changed option checks that the new data stream value has changed from the prior value. For the demo case of this video, the has changed option is better than is any, right? After the condition is satisfied, the automation will perform the value transfer from the datastream light sensor V pin to the datastream green LED V pin. That means when the sensor detects light, the value of the datastream light sensor V pin will be 0. This value 0 will be transferred to the datastream green LED V pin. With this value 0, the switch widget on the dashboard will be off and the green LED on the hardware side will also be off. Finally, we click on Save. Now I will move the light closer to the sensor. Then I move the light away from the sensor. The content of this video is related to automation, specifically with the type of condition being seen. Seen manually triggers an automation scenario from the Blynk.app mobile app or the Blynk.Console web app. In this video, I will create one automation to turn on all 3 switches and another automation to turn off all 3 switches. Here is a list of 3 data streams for the 3 switches. We turn on the action switches of all 3 data streams. Save and apply. We go to the Automations tab. For this video, we will choose this one. Click on Settings. Name the automation. This automation we will use it to turn on all switches. I choose this cover for the automation. Here we check all. Turn on all switches. Okay, now we click on Save. We create another automation. This automation we will use it to turn off all switches. I choose this cover for it. Here we also check all. The status of all switches here we leave off. Save. To execute the automation named Turn All on Automation, you click on this play button. We click on this button to turn on all switches. And click on this button to turn off all. The content of this video is related to automation, specifically with the type of condition being event. Event. Trigger automation when a certain event logged on selected devices. This is the starting code of this video. In the loop function, I write a command to catch the board event receiving a value from the computer via the UART protocol. When receiving the command log event, the board will send an event to Blynk. Okay, now we upload the code to the board. After uploading the code, I go back to the Blynk.Console interface. I click on this event. Click on the Settings tab. Here I choose 1 minute. Here I turn on the condition switch. Save. I go to the Datastreams tab. I click on this Datastream. Click on the Expose to Automations tab. Turn on the Action switch. Save. Save and apply. Now we proceed to create automation. I go to the Automations tab. I choose this. Click on Settings. Give it a name. I choose this event. After satisfying the condition, it will next turn on the event switch. After turning the event switch on, I let it wait for 1 minute. After 1 minute is up, the automation will turn off the event switch. Finally, click on Save. Remember to select this option. The device is currently online. Now I send to the board the string log event. You can see the interface on the Blynk side. The event switch is turned on. Because the event has been sent to Blynk. 3:54 and 17 seconds p.m. here, I will consider that as the time that Blynk received the event. When it reaches 3:55 and 17 seconds p.m., which is actually a little before 3:55 and 18 seconds p.m., the event switch is off. I send an event to Blynk again. Maybe when notifications and events was open, the status of the event switch was not updated. The content of this video is related to default value. You can see the related information on this page. So what is default value? Default value is a setting that allows you to set the initial value for the datastream. Usually, this setting is used to set the initial value when hardware boots up for the first time, provided the hardware has synchronization commands, such as the Blynk.syncVirtual command. Example: you are working on a smart light bulb and would like to turn it on when it first connects to the server after provisioning. What is provisioning? It can be understood as providing initial information such as Wi-Fi name, Wi-Fi password for IoT devices when you first buy them. If you want to use the sample code on this page, the following are some notes for you. This API command is no longer available. You can replace it with the Blynk.syncVirtual command and the call to this handle function. You need to define your own handle function before calling it. The content of this video is related to slider widget. If you haven't read this documentation page, you should read it once. The specific documentation page for slider widget of this video, you can see it here. The following is some information. A slider assigns a value to a data stream within a predefined range. The predefined range you can understand is that it is created from min and max values in a data stream. Usage examples: volume, brightness, RPM, flap position control, etc. Move slider handle to set the value or use fine control buttons plus and minus to set the value more precisely. The step defines the minimum increment of values generated in response to movement of the slider by the user. The range of values the slider will generate is defined by the datastream min value and max value settings. The units displayed will also come from the Datastream settings. The left window is the starting code of this video, and the right window is the schematic of this video. Before coding, if you have not installed this library, please install it. Here I write two macros. One macro named decreaseButtonPin with the value of 16 and one macro named increaseButtonPin with the value of 17. Next, I write code based on the button library. First, I include the library into the code. Next, copy and paste the sample code to initialize an object of button. We edit the code. Now we have two objects of button, decrease button and increase button. In the setup function, for each button object we call the begin method. In the loop function we catch the event when the user presses the buttons. Here I initialize a variable with the initial value of 0. This variable is used to store the current value of the slider. I write another macro. Here one step corresponds to the value of 5. The main content of pressing the decrease button is to decrease the slider value, and the increase button is to increase the slider value. We should decide the range for the slider. The range is based on two values, which are min slider value and max slider value. Here we write two more macros. Min is 0. And max is 100. After pressing the decrease button, if the difference between the current slider value and the fine control step is less than the min slider value, we assign the min slider value to the slider value variable, which means that the current slider value is equal to the min slider value. If the above condition is not satisfied, we assign the difference between the current slider value and the fine control step to the slider value variable. You understand the content of the code after the user presses the increase button, right? We need to write code to update the current slider value for Blynk or receive the slider value from Blynk, so we need to know the name of the virtual pin to update the value. You go to the Blynk.Console with the same interface. You click on Edit Dashboard. Here, you drag the slider widget to canvas. You click here. Title. This is the label shown at the top of the widget. The default is the name assigned to the datastream. Datastream, data type integer or double may be assigned. Click on Create Datastream. Select Virtual Pin. I decide to use pin V0 for this datastream. You write one more macro. Name it slider vPin. And its value is V0. Here, I assign the value received from Blynk to the slider value variable. In this video, on the hardware side, I do not use the LCD1602 screen to display the slider value. Instead, I use the serial monitor pane on the Arduino IDE. Color. The widget color takes on the assigned datastream color by default. Send values on release only, optimal. When enabled, the datastream is assigned a value only when the user releases the control, recommended setting. When disabled, all the values set as the user moves the slider will be assigned to the datastream. Handle step defines the minimum increment/decrement of the values as the slider position is changed by the user. The step value is a whole integer when the datastream data type is integer, and a decimal value when the datastream data type is double. In this information field, I set it to 10. Show fine controls adds a minus and plus to either side of the slider when enabled. The increment or step for this option is set by the Fine Control Step option. Fine Control Step defines the minimum increment/decrement of the values as the minus and plus to either of the slider is clicked by the user. This option is only visible when Show Fine Controls is enabled. Value Position sets the position of the slider value displayed to either the left or right of the slider handle. In this information field, I set it to 1. Save. Save and apply. Now we upload the code to the board. From now on, you watch the video and understand it yourself. The content of this video is related to number input widget. You can see information related to this widget type on this web page. The number input widget displays a numeric value and lets you increment or decrement the value using minus and plus buttons. The initial value is the Datastream default value, and the range of values are defined by the Datastream min value and max value, and so is the unit. This is the starting code of this video. Loop values. When disabled will cause the number displayed / generated by the control to stop increment / decrement of the values at the datastream min value and max value. When enabled, incrementing past the max value will continue loop, starting at the min value, and similarly decrementing past the min value will continue loop, beginning at the datastream max value. The primary functions of the program will be get the value of number input widget every time the user changes the value of the widget on Blynk, and update the value for Blynk every time the user changes the value at the hardware. The following are the operations of this program. First is control via Blynk. Blynk write number input v pin. This function is called every time new data is sent from the number input widget on Blynk. This data is stored in the number input value variable and then printed to the serial port. Second is control via serial monitor. Loop, the main loop of the program, checks if any commands are entered into the serial monitor. If you enter plus or minus into the serial monitor, the number input value will be increased or decreased by handle step, which is 2. There is a mechanism to ensure the value does not exceed max number input value, which is 10, or fall below min number input value, which is 0. If it exceeds the limit, the value will wrap around, e.g., 10 plus 2 will become 0. After the value is updated, the program uses Blynk.virtual write to send this new value to Blynk, which makes the number input widget on Blynk display the updated value. Okay, you upload the code to the board. The content of this video is related to image button widget. You can see information related to this widget type on this web page. The image button widget simulates a latching or momentary push button, with the two states, e.g. on/off, represented by a custom image. Mode defines the type of control, simulating either a momentary push button or a latching push button. Push, clicking the button and holding changes the widget state from off to on. Releasing the button will return the widget to its original state. Switch, clicking the button will change the state between the options of off and on. The main use case for this widget is same as for on/off switch widget, but enriched with images. Images. Assign a URL that links to an image accessible online to each of the two states of off and on. A shortened URL will not work. Images scaling adjusts how the image will be scaled to fit the widget. Fit. The image will be scaled to fit the height or width of the widget size. Fill. The image will be scaled to fill the widget area. Cropping may occur. This is the starting code of this video. If you haven't installed this library, please install it. The following are the primary functions of this program. The program establishes a two-way connection between an ESP32 development board and the Blynk platform. When you press or release the physical button connected to the ESP32, its state is sent to Blynk. Conversely, if you press or release the image button widget on Blynk, its state is sent to the ESP32 development board. And the following are the configuration and operation of this program. First, Blynk setup. Image button vPin, or virtual pin v0, is the channel used for communication between the physical button and the image button widget. Second, hardware configuration. The physical button is connected to pin 0 of the ESP32 module, defined by image button pin. The program uses a button library to easily detect when the button is pressed and released. Third, control via Blynk. The Blynk write image button vPin function is called automatically whenever the image button widget is tapped on Blynk. It reads the new state, true for pressed, false for released, and stores it in the image button state variable. The state is then printed to the serial monitor. Fourth, control via physical button. The loop function constantly checks the state of the physical button. When the button is pressed, the program updates image button state to true, then uses Blynk.virtual write to send this state to Blynk. When the button is released, the image button state is updated to false, and this change is also sent to Blynk via Blynk.virtual write. Each state change is also printed to the serial monitor, providing a real-time log of the button status. Okay, now you upload the code to the board. Before uploading the code to the board, let's see the key differences of this new program from the previous program. First, setting image URLs from hardware. The Blynk connected function is new here. When the ESP32 development board connects to Blynk, it immediately sets the URLs for the two images that the image button will display. Off image is set to the check image, and on image is set to the close image. This means the button's appearance in the dashboard will change. Second, toggle logic. In the loop, when the physical button is pressed, the program uses a different logic. Reverse the value of the image button state variable, then assign the result to the image button state variable. This is a toggle. Instead of having separate logic for pressing and releasing the button, a single press now toggles the state from true to false or vice versa. The previous program was designed for a button where you'd hold it down to trigger an on state and release it for an off state. This new logic is for a button you press and release once to change the state. Okay, now you upload the code to the board. The content of this video is related to web page image button widget. You can see information related to this widget type on this web page. This widget allows you to display any image and open any external or even Blynk.Console internal page in the new tab on click. You need to provide a http:/s URL for the image. You can set up two images representing the pressed/unpressed state of the button and an URL field for the external page address. The button operates in push mode. On finger released, the button will switch to the default state. Datastream. When you click on the image, the widget doesn't send any values to the server, but Datastream is still required as it is used for set property actions. URL to the web page that is opened on click. Images. Off image for default button state. On image for pressed button state. This is the starting code of this video. The sole purpose of this program is to set the properties of the QR web page image button widget on Blynk. When the ESP32 development board successfully connects to Blynk, it sends the configurations to Blynk to define the behavior and appearance of the QR code web page image button widget linked to virtual pin v1. This line sets the URL that a browser will open when a user taps the QR code web page image button. In this case, it's a link to a QR code image on a GitHub page. This line sets the image that will be displayed on the button when its state is default. The image is a dark blue QR code icon. And this line sets the image that will be displayed on the button when its state is pressed. The image is a dark gray QR code icon. Now we upload the code to the board. Maybe we need to reload the dashboard page before clicking on the button. The content of this video is related to LED widget. You can see information related to this widget type on this web page. This is the simplest widget that allows to visually determine brightness or color density of your device's LED. Color. Select a color you want from the palette. The left window is the starting code and the right window is the schematic of this video. The RGB LED I use has the common pin as cathode. The program needs this library. If you haven't downloaded it yet, download it. The primary purpose of this program is to control an RGB LED. We can control it from our computer using the serial monitor. The dashboard of the device will act as a display, receiving information from the ESP32 development board to update the LED state and color. In short, you type a command on your computer, and both the physical LED and the widget on the dashboard change accordingly. Now, let's take a look at how this program operates. First, hardware configuration and initialization. We initialize an object and some variables. The RGB LED object, which is created to control the physical LED. We specify the pins as 15, red, 16, green, and 17, blue. And we identify the COM as common cathode. The Boolean variable RGB LED state to store the on/off state, which is initialized to false, off. The unsigned long variable color value stores the color value, which is initialized to 0, black. In the setup function, the program uses these initial values to set the LED's color to black and turn it off before proceeding to connect to the Wi-Fi network and Blynk. Second, using virtual pin V0. An important detail is that the program uses virtual pin V0, or RGB LED V pin, to communicate with Blynk. This virtual pin acts as a data channel, allowing the ESP32 development board to send information about the LED state and color to the corresponding widget on Blynk. When the ESP32 connects successfully, the Blynk connected function is called. The following are its jobs: sending a configuration to Blynk to ensure the LED color is also set to black, and sending a command to Blynk to ensure the LED state is also set to off initially, keeping those two things synchronized from the start. Third, control via serial monitor. Inside the main loop function, the program continuously listens for commands from the serial monitor. You can enter 3 different types of commands. If you type on, the LED will turn on, and this on state will be sent to Blynk. If you type off, the LED will turn off, and this off state will also be sent to Blynk. Finally, if you enter a hexadecimal color code, such as FF0000 for red, the LED will change to that color. The program will also send this color code to Blynk, ensuring the color on the dashboard perfectly matches the physical LED. Now you upload the code to the board. The content of this video is related to Gauge widget. You can see information related to this widget type on this web page. A great visual way to display incoming numeric values, e.g. temperature, pressure, volume, etc. Level color. With disabled option change color based on value, pick your own color from palette. With enabled change color based on value, select the gradient scheme or set up your own one based on the min and max values that you select. With the change color based on value switch enabled, this information on the web page is outdated compared to the web interface I implement. This is the starting code of this video. I am going to write a program whose main function is to send the value entered in the serial monitor to Blynk to update the value for the gauge widget. Okay, now you upload the code to the board. Before you send a value to Blynk, remember to select No Line Ending. Reload the page. The content of this video is related to the radial gauge widget type. This widget type is similar to the gauge widget type. However, it has some differences. First, the value comes from the top of the widget instead of from the bottom like the gauge. Second, its min and max values are not displayed on it. Now, you can see here there is a line with 3 circle points that have 3 different colors. From left to right, the first is white, the second is blue, and the third is a color like orange. Here, there is an invert gradient button. You can understand that when you click on this button, the positions of the circle points on the line will be inverted. In this case, you can see this figure to understand how it inverts. One more case, in this case, the line has 4 circle points that also have 4 different colors. In this case, you could see this figure. This is the code of this video. Now we upload the code to the board. I enter 0 into the serial monitor. The content of this video is related to the alarm and sound widget type. You can see information related to this widget type on this web page. The alarm and sound widget creates an alarm in the Blynk.Console. It is triggered by a datastream value other than 0. Any integer value other than 0 will trigger the alarm. The alarm can be disabled by changing the datastream value to 0. About the widget controls, the alarm and sound widget has the following controls. First, on/off, disables, mutes the alarm, or resets it. Here, in my opinion, on corresponds to unmute and off corresponds to mute. Second, alarm sound. When the allow end user to change the sound widget option is enabled, the user can select the alarm sound to be played when the alarm is triggered. You can see here, this is the to-do list of this video. Let me read some to you. To-do list. First, add an alarm and sound widget with setup to a dashboard of a device. Second, write code to A. Trigger the alarm from the hardware. B. Stop the alarm from the hardware. C. Mute the alarm from the hardware. D. Unmute the alarm from the hardware. E. Receive the pin value related to the alarm and sound widget. Third, working testing. Okay, let's get started. First, add an alarm and sound widget with setup to a dashboard of a device. Second, write code. This is the starting code of this video. I will not use the Blynk connected function. If you want to prepare code like this, don't add it to the code. Okay, write code to A. Trigger the alarm from the hardware. B. Stop the alarm from the hardware. C. Mute the alarm from the hardware. D. Unmute the alarm from the hardware. E. Receive the pin value related to the alarm and sound widget. Okay, now I upload the code to the board. Now, we go to the third section, which is also the last section of this video. Third, working testing. First, we trigger the alarm from the hardware. Then stop it from the hardware. Next, trigger the alarm from the hardware. Then stop it from the dashboard. Mute the alarm from the hardware. If the dashboard does not show the new value yet, follow my way to make the dashboard show the new value. Then trigger it from the hardware. And then stop it from the dashboard. Unmute the alarm from the hardware. Then trigger it from the hardware. And then stop it from the dashboard. Mute the alarm from the dashboard. Then trigger it from the hardware. And then stop it from the dashboard. Unmute the alarm from the dashboard. Then trigger it from the hardware. and then stop it from the dashboard. Change the alarm sound. Then trigger the alarm from the hardware. And then stop it from the dashboard. The content of this video is related to the chart widget type. You can see information related to this widget type on this web page. You can see here, this is the video outline for this video. Let me read it to you. First, opening. Second, objectives. Third, opening theory. Fourth, adding a chart widget with my custom setup to the device dashboard. Fifth, showing the data push program. Sixth, explaining the program. Seventh, uploading the program to the board. Eighth, letting the ESP32 development board push the data to the dashboard for 3 minutes. 9th, calculating average. 10th, finding min. 11th, finding max. 12th, clicking and dragging to zoom. 13th, clicking to hide or show a pop-up. 14th, what values does the chart display? The chart widget helps you to visualize live and historical data from multiple data streams with a data type of integer or double. You can use it for sensor data, for binary event logging, and more. The data may be plotted as a line, area, column, bar, or a step line. Values axis vertical. Each data stream added to chart widget has its scale on the right and left. It can be set manually or to be auto-scaled during template dashboard setup. Timeline axis, horizontal, helps to find values actual for the exact time the search is performed. Hover the chart views value and time for each selected point for each data stream. Okay, I am going to add a chart widget with my custom setup to the device dashboard. Data streams. Multiple data streams may be plotted on the chart. Remember to enable this. Edit chart. This option to the left of each data stream allows you to customize the appearance of the data stream values in the chart. Max, min, average. Choose between plotting the average, max, and minimum value. Move source allows you to change the order of data streams in the legend. Auto scale automatically scales the y-axis. Fifth, showing the data push program. I am going to show you the code. Sixth, explaining the program. Put simply, this program just pushes the data to the dashboard every 6 seconds. One single Blynk timer instance schedules one timer. The program will call the timer handler function every 6 seconds. Here, I initialized an array named values, which contains 60 values. For this function, I initialized one variable to store the next position. Before finishing the function, the value of the position variable will be changed, either increased or reset. In the function, first, the program will push the data to Blynk. The data is the value at the position in the array. Then it prints the position and the value to the serial monitor. Seventh, uploading the program to the board. I'm going to upload the code to the board. Eighth, letting the ESP32 development board push the data to the dashboard for 3 minutes. Okay. Ninth, calculating average. Tenth, finding min. 11th, finding max. Twelfth, clicking and dragging to zoom. 13th, clicking to hide or show a pop-up. 14th, what values does the chart display? What values does the chart display? In this case, 2 is the minimum value of the displayable range of the chart. You can see a little orange here, it's 2. And 12 is the maximum value. But the value of 1 still shows a pop-up, and the value of 0 you can see before does the same. The values in the displayable range are orange, and the lower values are not. So, and the higher values? Here I have one more picture. The difference between this picture and the previous one is the difference between the two widget ranges. The content of this video is related to the image gallery widget type. You can see information related to this widget type on this web page. This is the video outline of this video. Let me read it to you. First, opening. Second, objectives. Third, opening theory. Fourth, adding an image gallery widget with my custom setup to the device dashboard. Fifth, first working on the device dashboard. Sixth, starter code. Seventh, coding task. Replacing the list of images from the hardware. Eighth, coding task. Sending indexes to the dashboard. 9th, uploading the code to the board. 10th, replacing the list of images from the hardware. 11th, sending indexes to the dashboard. Okay, we are going to the opening theory. Image gallery is used to create sets of pictures and display one of them accordingly to what is needed at the moment by changing attached datastream value or index. Okay. Fourth, adding an image gallery widget with my custom setup to the device dashboard. Add image, click this button to add image, 20 is maximum, and provide its URL. Move. Hold this button and move the image in order to change its view order and index. Once it's set up, you can change the image displayed while the device is on or off, as an example above. This figure shows a priority regarding what values a widget will get for its properties when the widget is displayed, and in case its properties were set values from both hardware and widget settings. The interpretation of the figure. When a widget is displayed in a dashboard, the widget prefers to get values for its properties from memory A over B. Fifth, first working on the device dashboard. Sixth, starter code. Seventh, coding task. Replacing the list of images from the hardware. Eighth, coding task. Sending indexes to the dashboard. Ninth, uploading the code to the board. 10th, replacing the list of images from the hardware. 11th, sending indexes to the dashboard. The content of this video is related to the custom chart widget type. You can see information related to this widget type on this web page. This is the video outline of this video. Let me read it to you. First, opening. Second, objectives. Third, opening theory. Fourth, creating 4 data streams. Fifth, adding a custom chart widget with my custom setup to the device dashboard. Sixth, showing a data push program. Seventh, speaking about the program. Eighth, uploading the program to a board. Ninth, letting the ESP32 development board push data to the dashboard for about 3 minutes. 10th, speaking about some things on the chart. 11th, what is the loads data in 1 week chunks. 12th, speaking about some values on the chart. The data aggregation is the average. 13th, changing the data aggregation to the raw. 14th, what is the loads data in 3-day chunks. 15th, speaking about values on the chart. The data aggregation is the raw. 16th, changing the data aggregation to the sample. 17th, what is the loads data in 1 week chunks. 18th, speaking about values on the chart. The data aggregation is the sample. Third, opening theory. The custom chart widget is a chart that is fully configurable by your users. You add the widget to your template web dashboard, and then you or your users may customize it from the device console. It can be a good idea to create a separate tab in your device web dashboard, especially if you need different access permissions for it. About creating a separate tab, you can see this plus here. Here we need to upgrade to add more tabs. Fourth, creating 4 data streams. The data streams must already exist prior to customizing the chart. With the advanced settings, save raw data and show in custom charts enabled for them. Remember this. I don't enable the save raw data. If you want to enable this, you need to upgrade first. For the first 3 data streams, I will leave them with enabling the show in custom charts. For the 4th data stream, I disable the show in custom charts. Fifth, adding a custom chart widget with my custom setup to the device dashboard. Default data streams. Select the list of data streams of any data type: integer, double, string, enumerable, GPS, that will be shown to the end user by default. Users can later adjust this list as needed. Data aggregation. Define how the data will be aggregated. Raw plots all available data points without aggregation. Best for detailed, high-frequency monitoring. Loads data in 3-day chunks. Average plots the average value per minute. Useful for smoothing out fluctuations and identifying trends. Loads data in 1-week chunks. Sample plots every XTH raw value, e.g., every 2nd, 5th, or 10th, depending on the amount of data sent by your device. Useful when your device is sending signals instead of continuous updates, providing a clearer picture of periodic events. Loads data in 1-week chunks. Each aggregation type has a 100,000 data points per data stream limit. Before I click the Save button, you need to remember, I have chosen the average here. 6th, showing a data push program. 7th, speaking about the program. This program will push data to the Blynk every 12 seconds. More specifically, the data for 3 data streams are the results of the random function calls. The results will be in the corresponding ranges. After the program executes the data send commands, then the program will print a line with the values. 8th, uploading the program to a board. 9th, letting the ESP32 development board push data to the dashboard for about 3 minutes. 10th, speaking about some things on the chart. You can see in the middle of the chart, there is a text, no data. You can follow my following actions to display the data. Okay, it displayed the data. You see this? There are 3 data stream names. You can choose more data streams. In here, we don't see the 4th data stream. Why? Because I have not enabled the show in custom charts. Now you can see it here. If you close this dashboard, and then you open it, the data stream you just added has disappeared. If you remove this data stream, and then you close the dashboard, and then you open it, the T3 data stream has came back. That means if you open the dashboard, the chart will only show the default data streams. This is the value axis. This is the time axis. This is maybe a slider that can adjust the time period displayed. You can zoom in on the time axis this way. You can click this button to enter full screen. Eleventh, what is the loads data in 1 week chunks? You can see this slider. When I hover over it, I can see a tooltip appear. This time range includes 7 days, from September 6th to September 13th. Now, if I adjust the slider, I can load different data in 1 week chunks, such as from September 5th to September 12th, or from September 4th to September 11th. After you zoom, you can use this slider to see time ranges more specifically. In this case, the chart will not load data while you adjust the slider. 12th, speaking about some values on the chart, the data aggregation is the average. These 3 lines of 1618. The values related to 4:18 p.m. are displayed on the chart. Next, I will show you how to find results similar to the chart. 13th, changing the data aggregation to the raw. Do you remember that I have set the data aggregation to average just now? But now it displays as raw. But actually, the settings data that has been saved has been average, not raw. Fourteenth, what is the loads data in 3-day chunks? Now you can see here, it shows from September 10th to September 13th, from September 9th to September 12th, and now it is from September 8th to September 11th. Loads data in 3-day chunks, right? 15th, speaking about values on the chart, the data aggregation is the raw. You can see the values displayed here are similar to before I changed the data aggregation to raw from average. Why does the chart display like that? Maybe it is because I have not enabled Save Raw Data. 16th, changing the data aggregation to the sample. You see, it happened again. Seventeenth, what is the loads data in 1-week chunks? Similar to the average. 18th, speaking about values on the chart, the data aggregation is the sample. Similar to the previous two ones. Again, maybe it is because I have not enabled Save Raw Data. The content of this video is related to the Heatmap chart widget type. You can see information related to this widget type on this web page. This is the video outline of this video. Let me read it to you. First, opening. Second, objectives. Third, opening theory. Fourth, creating an enum datastream. Fifth, adding a Heatmap chart widget with my custom setup to the device dashboard. Sixth, showing a data push program. Seventh, speaking about the program. Eighth, uploading the program to a board. Ninth, letting the ESP32 development board push data to the dashboard. 10th, changing the data aggregation to the min. 11th, changing the data aggregation to the max. Third, opening theory. Heatmap chart is a two-dimensional visual representation of data, where x-axis is time and y-axis is a value visualized with color intensity. An example of use could be a chart of temperature change depicted in color, but it can also be used to visualize on off or mode states. Fourth, creating an enum datastream. Datastream. It's possible to plot up to 5 data streams in one widget. Only integer, double, and enum data streams are supported. When using enum type, colors will be taken from datastream settings. For others, you can set your own color mapping. Fifth, adding a Heatmap chart widget with my custom setup to the device dashboard. In the documentation, I see one more data aggregation type. This is it. Maybe you need to enable the Save Raw Data first. Enum will only work with raw aggregation type. I don't understand this line. If you see the later part of this video, maybe you will also be confused. When using Enum Datastream, colors will be taken from Datastream settings. For others, you can set your own colors. Sixth, showing a data push program. Seventh, speaking about the program. The program will push a value to the Blynk every 30 seconds. Each time is a value corresponding to the index in the array. After pushing the last value, the index will be reset. Eighth, uploading the program to a board. Ninth, letting the ESP32 development board push data to the dashboard. Tenth, changing the data aggregation to the min. Eleventh, changing the data aggregation to the max. Why doesn't it display purple, but instead displays this color? Why? Maybe it displays colors based on the gradient. You can see here it does not include purple. And this color is similar to the Datastream color. The content of this video is related to the video widget type. You can see information related to this widget type on this web page. This is the video outline of this video. Let me read it to you. First, opening. Second, objectives. Third, opening theory. Fourth, Adding a video widget with my custom setup to the device dashboard. 5th, showing the program. 6th, speaking about the program. 7th, uploading the program to a board. 8th, changing the URL from the board. 3rd, opening theory. The video widget allows you to display static, live, and streaming videos contained within a M3U8 playlist. At the moment, Blynk doesn't provide streaming servers, so you can either stream directly from the camera, use third-party services, or host your own streaming server, on Raspberry Pi for example. 4th, adding a video widget with my custom setup to the device dashboard. Fifth, showing the program. Sixth, speaking about the program. You can change the URL of the video widget by entering a URL string into the serial monitor. 7th, uploading the program to a board. 8th, changing the URL from the board. 'The content of this video is related to the Bitmask table widget type. You can see information related to this widget type on this web page. This is the video outline of this video. Let me read it to you. 1st, opening. 2nd, objectives. 3rd, opening theory. 4th, setting up in Blynk.Console. 5th, showing the program. 6th, speaking about the program. 7th, uploading the program to a board. 8th, working. 3rd, opening theory. This widget helps display a table of values as LED indicators. The hardware sends a Bitmask value, which the server parses to update LED states automatically. Each bit represents the on-off status of an LED on the corresponding row. What is a bitmask? A bitmask stores multiple true, false binary values in a single integer. Each bit represents a separate state, e.g., an error, alarm, or status. 1 corresponds to on true. 0 corresponds to off, false. How the server parses the data. When the hardware sends a bitmask as an integer, the server extracts individual bit states to update the table. Example: a device has 11 error states. Actually, in the figure below, the error list has 12 errors, each represented by a bit in a bitmask value. If an error occurs, the corresponding bit is set to 1, turning on the LED in the respective row. This line, received integer, 123. That means the server received a value of 123. In this figure, you can understand that the device executed a send command to send a value to the server. This value is an integer, or in other words, this value is a decimal. From this decimal, the server converts it to binary, 1111011. You can see the map states here. Here, the limits of the widget. 4th, setting up in Blynk.Console. 1st, I am creating 4 data streams for 4 switch widgets. Next, I am going to set up a Bitmask table widget. This widget will present the states of the 4 other widgets. Why do I set max to 15 here? If you learn about binary, you will know that a binary number with 4 digits which will represent 16 different values, of course, it includes 0. About this switch, you can read the information here. Hide false values, hide rows with a false, 0 value. But when you try to change its value, nothing happens when you see the widget on the right side. Okay, now I need to add for more switch widgets. Fifth, showing the program. Sixth, speaking about the program. First, about the getDecimal from function, this function allows us to pass a binary list with a list size. Here, the binary list is an array to store binary number digits. The list size is the size of the array, or in other words, it is the number of digits of the binary number. The main function of this function is to convert a binary number to a decimal number. Second, the update Bitmask table function. In this function, first, it will take all the values of the 4 state variables. You can see these 4 states are arranged in an array. Next, it converts the binary list to a decimal number. Then it pushes the decimal number to Blynk. The Blynk writes functions. The function of these functions is updating values for the corresponding state variables, and then it updates the Bitmask table. Seventh, uploading the program to a board. Eighth, working. The content of this video is related to the gradient ramp widget type. You can see information related to this widget type on this web page. This is the video outline of this video. Let me read it to you. First, opening. Second, objectives. Third, opening theory. Fourth, setting up in Blynk.Console. Fifth, working. Third, opening theory. The gradient widget provides intuitive data visualization through a sloped bar with a smooth color gradient. It's designed to represent values on a continuous scale, helping users interpret trends, thresholds, and performance metrics at a glance. Common use cases include displaying signal strength, temperature levels, battery status. About settings you can see here. And here, limits of the widget type. Fourth, setting up in Blynk.Console. Fifth, working. The content of this video is related to the text input widget type. On the Blynk.Console section, I did not find the documentation web page for this widget type. But on the Blynk.app section, it has a documentation web page related to this widget type. You can see the web page here. This is the video outline of this video. Let me read it to you. First, opening. Second, objectives. Third, opening theory. Fourth, setting up in Blynk.Console. Fifth, working. Third, opening theory. Displays the latest data stream of data type string value and allows the user to enter and assign a new text value. Widget controls. The widget only has a text display, input field. Fourth, setting up in Blynk.Console. Fifth, working. The content of this video is related to the terminal widget type. You can see information related to this widget type on this web page. This is the video outline of this video. Let me read it to you. First, opening. Second, objectives. Third, opening theory. Fourth, setting up in Blynk.Console. Fifth, showing the program. Sixth, speaking about the program. Seventh, uploading the program to a board. Eighth, working case, add new line, is enabled. Ninth, working case, add new line, is disabled. Third, opening theory. Terminal widget works like the usual system terminal. This widget displays Datastream text in a multi-line window and optionally provides a text input area which allows sending any string to your hardware. Options allow a new line character to be added to each Datastream change in value, scrolling, and the text and background color of the display and input area. Fourth, setting up in Blynk.Console. Add new line. Enable to have each change to the datastream prefaced with a new line character. When disabled, all new text will be concatenated directly after the last. Auto scroll automatically scrolls the text display in the output window vertically to show the latest at the bottom. Useful only when add new line is enabled. Fifth, showing the program. Sixth, speaking about the program. With this program, you can send a line of text to Blynk or receive a line of text from Blynk. Seventh, uploading the program to a board. Eighth, working case, add new line, is enabled. Note that a horizontal scroll bar below the output display becomes visible when the text in the current line exceeds the width of the output display. Ninth, Working case, add new line, is disabled. The content of this video is related to this segmented switch widget type. You can see information related to this widget type on this web page. This is the video outline of this video. Let me read it to you. First, opening. Second, objectives. Third, opening theory. Fourth, setting up in Blynk.Console. Fifth, working. Third, opening theory. Unlike the basic switch widget that can only have 2 statuses, with segmented switch you can switch between up to 10 statuses or options. This widget works with enum and integer data streams. Fourth, setting up in Blynk.Console. Name the segmented switch widget by filling out the title field, or leave it blank if you want to hide the widget name. Datastream. If you use enum Datastream, all options will be automatically loaded. Choose whether you want to use icons next to each label for options or just labels. Fifth, working. The content of this video is related to the menu widget type. On the Blynk.Console section, I did not find the documentation web page for this widget type. But on the Blynk.app section, it has a documentation web page related to this widget type. You can see the web page here. This is the video outline of this video. Let me read it to you. First, opening. Second, objectives. Third, opening theory. Fourth, setting up in Blynk.Console. Fifth, working. Third, opening theory. Menu creates a list of 2 or more text-labeled menu items for the user to choose from. 4th, setting up in Blynk.Console. Fifth, working. The content of this video is related to the module's widget type. You can see information related to this widget type on this web page. This is the video outline of this video. Let me read it to you. First, opening. Second, objectives. Third, opening theory. Fourth, setting up in Blynk.Console. Fifth, working. Third, opening theory. This widget is extremely useful in cases your product devices use detachable modules that can be attached accordingly to use conditions. Each module has its own tools, units, details that are represented by Datastream sets configured under each module. Fourth, setting up in Blynk.Console. Warning: check the data streams you want to use in modules to have Save Raw Data option enabled. If you want to enable Save Raw Data option, you need to upgrade first. And if you want to read information related to save raw data, you can read here. Is enabled Datastream, turn on off Datastream that makes all other data streams that are related to the module visible in display data. Example, your module is fan, it has Datastream V0. Once you attach the fan to the socket V0 switches from 0 to 1 that enables all other data streams values display, such as RPM, fan LED color, voltage, etc. Display data, set up datastream sets and their view for each module you add. Add datastream, click to add and set up data streams which values or states will be displayed. Set view type, define data streams values. Status view by accessing drop-down menu on the right of the selected data stream. Note, type limitations can be applied in the list accordingly to the selected datastream properties. Modules arrangement inside the widget set vertical or horizontal order. Scroll bar will appear if there are a lot of modules. This switch is used to show or hide module 1. This switch is used to show or hide module 2. This switch is used to present synchronization with the switch of module 1. This text input is used to present synchronization with the DS value string of module 1. This switch is used to turn on, off the color LED of module 1. This switch is used to turn on, off the text and color LED of module 1. This number input is used to present synchronization with the number and units of module 1. This number input is used to present synchronization with the number input of module 1. And this slider is used to present synchronization with the level of module 1. Similarly, this switch is used to present synchronization with the switch of module 2. This text input is used to present synchronization with the DS value string of module 2. Fifth, working. Reload this page. Exercise. Project name, Blynk Garden. Preparation, 1 soil moisture sensor module, 1 relay for a water pump, 1 relay for a light, etc. Requirements, adding the location to the device. Let users add Wi-Fi credentials and Auth token to the device themselves. 1 switch on Blynk.Console, the color of the switch is normally green, to turn on off the water pump relay. Allow users to reboot the device from Blynk.Console. The device can update its new firmware remotely. 1 button on the hardware to turn on, off the water pump relay. Synchronizing the water pump relay state between Blynk and hardware after turning on, off from both sides. Synchronizing the water pump relay state between Blynk and hardware after the device is online. 1 label on Blynk.Console to present the soil moisture sensor value. Updating the soil moisture sensor value every 1 minute to Blynk with this format. 1 switch on Blynk.Console to turn on, off the auto mode. The auto mode, turning automatically on, off the water pump relay based on the soil moisture sensor value when this mode is on. If users control any relays from any sides by using different functions, then the auto mode will have to be off. If you turn on the water pump relay when the auto mode is off, and then the soil moisture sensor detects that the soil moisture exceeds the threshold, then you need to change the color of the switch to red and show an event. Show the event in Notifications and Events section. Be able to schedule to turn on, off the water pump relay. The light relay turns on when the sun sets and turns off when the sun rises automatically. 1 image gallery to present the value of the soil moisture sensor. Example. When the soil moisture exceeds the threshold, the image gallery presents a corresponding image, otherwise presents a different image. Creating a scene, this scene is used to turn on, off all relays. When the event is triggered, send an email to users to warn them.